Okay, first unit is organic chemistry. So we have lots of naming reactions and kind of is mostly the rules you have to follow for the namings. So organic chemistry, what is the organic? No, anything that has carbonic group, carbon, hydrogen, oxygen, they are organic groups. So here is the definition: a group of organic compound with common structural feature that impart characteristic physical property and reactivity. Like what? Alkene. See, they have double bond. Any compound with double bond between the carbon is alkene. So here is like a family. Here we have carbon, hydrogen, oxygen, hydrogen. So again, this is organic, and this is alcohol. We have alcohol, we have ketone, we have alkane, alkyne, alkene. So all of this, we will learn what they are. So okay. Now I'm going to explain that. So let's just explain double bond with carbon. See, if I have CH4, how do I draw that? It's easy. Carbon has 4 valence electron, right? And hydrogen has 1 electron in a valence. I have 4 hydrogen, so I just put it here, here, and here. So then you connect each. So these two couple, so make a bond. So this is easy, right? But if I get C2H4. Now we have 2 carbon. You know, again, around the carbon gonna be 4 bound for a lone electron. I have 4 hydrogen. I put 2 of them here for this carbon. And 2 of them, I put it here. As you see now, each hydrogen with this lone electron make a bond. And see, between carbon, I need to have double bond, right? So this is double bond. Again, when we have C2H2, carbon, carbon, 1 hydrogen for this, 1 hydrogen for that, because I have 2 hydrogen, right? Then there is a 3 electron around carbon, 3 more electron, because the carbon has 4 electron, right? 1 of them is shared, now 3 more. Therefore, between carbon need to have triple bond, right? Do you have any question, Carlos? Understood?
Yeah.
So we call it alkane. If you have single bond, double bond is alkene, triple bond is alkyne. We'll see that better next. Like, just wait a minute. I will get to the naming as well. You will see those coming. So hydrocarbon, I told you we have alkane when you have single bond. CH3, see we have, this is C2H6. Between carbon and carbon is single bond, if you draw that. If the carbon is coming within the cycle, see these big balls here, they are carbon. There is 6 of them attached to each other, because each of these carbon attached to the 2 carbon. So there is 2 lone electron need to be shared with hydrogen. So this white ones here is hydrogen. we have 12 of hydrogen in this cycle. If this is kind of is around attached to each other, we call it cyclo. Okay, we'll get to the naming. And double bound, if you have double bound like C2H4 that I did, is alkene. And triple bound, as we talked, is alkyne. So we have alkane, alkene, alkyne, and we have cyclo. This is kind of describing what they are. Here is benzene. I will explain benzene later, maybe, for you. Now, aromatic hydrocarbon is a compound with a structure based on benzene, a ring of 6 carbon. Maybe I just tell you what is that. So, benzene is C6H6. Means you have carbon, 6 carbon in the ring. 1, 2, 3, 4, 5, 6. I just put 6 carbon, attach them. See, the carbon has 4 electrons. Now, 2 of them is here. I need to have 2 more, right? That's why each carbon, okay, let me just erase that. Okay, in the benzene, every other bond that you see inside this circle will have a double bond. Like this is double bond. Now this one doesn't have, this one have, and this one have, right? As you see, the carbon has 3 electrons, 1, 2, 3. I need 1 more, true? I need 1 more electron, which is, this will be bounded with hydrogen. Hydrogen, hydrogen, hydrogen. So this is benzene. This double bond can be rotated. Like this double bond could be here, and this one could be here, and this one, like if I just do it with the red, this double bond could be here, here, and here instead of there, right? That's why, because this is kind of rotating. If you go to the textbook, you will see the benzene most of the time in this form. They put it like a circle, means this double bond is rotating around. And they don't show the hydrogen for you, but you need to know there is a carbon at each edge. This edge is carbon, this edge is carbon, we have 6 carbon. And you kind of, this is another model to show this hydrocarbon. Any question?
No.
Now, here is alkane. Okay, let's just look at this Greek letters. When there is just 1 carbon, we say met. 2 carbon is et. 3 is prop. 4 is but. 5 is pent. 6 is hex. 7 hept. 8 oct. 9 none. And 10 is dec, right? Just, you need to memorize that. If you have a simple hydrocarbon like a CH4, because this is 1 bound, it is single bound, and 1 carbon means met. Since it is just single bound, you are adding A and E, because this is alkane. Alkane is single bound, so you have to add A and E. C2H6, if you draw it, you will have again single bond, because this 2 carbon are going to be ethane. Here, propane, butane, pentane, and so on. Okay? Like if I want to do the propane, see 3 carbon, 1, 2, 3 carbon, and 8 hydrogen, right? So of course, this is 1 here. I need to have 3 hydrogen here, 2 hydrogen here, and here is 3 hydrogen. If you count the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, right? 8 hydrogen means this is single bound, and this is gonna be propane. It's 3 carbon, and it is alkane. Any question? Okay, so some of the naming, I'm going to explain this one at the end, right? Just hold on to this. Let's just work with the naming. Let's say I want to name that. The first things you do, find the longest chain. Let's see, start from here. Is 1, 2, 3, 4, 5. If I just start here and end here, it is 5 carbon there. Let's see if I have more. 1, 2, 3, 4, 5, 6. Now, if I start here and end here, 6. Probably is going to be longest. Let's see. 1, 2, 3, 4, 5, 6. Again, this is 6. If I start here and end here. 1, 2, 3, 4, 5, 6. Again, this is 6. Means the 6 is my longest, true? So I decide this one to be 1, 2, 3, 4, 5, 6. This is my main chain. This is my main chain. Now I'm gonna know that you have branches, right? This is your branches, this is your branches, this is your branches. So your main chain is 6, means this is hex. Since this is single bond, you have to say it's alkane, so A-N-E, hexane. Now I need to put my branches before that. So I have 2. So if you go back, there's like a 2 carbon there, right? See, 2 carbon is et. 1 carbon is met. So this is et, right? But since this is branch, you are adding Y-L-E, ethyl. Okay? And this is ethyl, and this is what? This is methyl. This is met. Okay, now, but I need to put the position. Here's on 3rd position, true? On 3rd position and on 4th position, I have 2 of them. So that's why I put di. Di means 2. Diethyl. Now on 5th carbon, I have what? Methyl. But wait, if I started to say 1, 2, 3, 4, 5, 6, I would get a lower number, right? Perhaps I have to start saying this is 1, 2, 3, 4, 5, 6. Then I get lower number, right? I get 4, 3 here, same thing. And I get, instead of the 5 here, I get what? I get 2. So you have to count it from a place that give you lower count. Any question? Okay, that would be, let me just double check. 3 diethyl 2 methyl hexane. This is another question. Again, you have to find the longest chain. See, this is the longest chain. 1, 2, 3, 8. You have 8 there. So 8 is going to be oct. So it's going to be octane. And a 3rd carbon, you have what? This. But here is didn't attach it from the beginning, right? That's why this is the T. Where is this one? This is S-butyl. If the chain is attached from the 2nd carbon and is 1, 2, okay, so this is 4. That was 3, right? That was this. Okay, let me just go back to the question. Which one was that? You have 3 of them, right? That is attached. These 3 attached to your main chain, this branch, attached to the main chain from the middle carbon. So that's why this has a special name, is isopropyl. If this 3 is attached from the beginning to the main chain, you have N-butyl. if you have your branches to be 4 carbon attached from the head, it is N-butyl. If you have this structure, see it's 4, but it's attached from this end, is isobutyl. Again, you have 4 of them attached from second carbon to the main chain, is S-butyl. And if this is T-shape and attached from the middle carbon, is T-butyl. Okay, anyway, that was S-butyl, true? That's why you say, oh, this is another naming. 3, because on the third carbon, isopropyl octane. You got it? Or you can have another naming as well, but let's say this is your main chain. Again, you have 8 carbon, right? In your main chain. On second carbon and third carbon, you have branches. On third one, 3, you have ethyl. And the second one, you have methyl. Make sure you write it alphabetically. E comes first, then M coming, true? Now draw a structure diagram for 1,3-diethyl cycle. So this is cyclopentane, means you put 5 carbon in a chain. 1, 2, 3, 4, 5. I know it's a little bit. 1, 3. If this is the first one, let's say, it doesn't matter which one you take it first. 1, 2, 1 on the first one. 1, 2, 3. On the third one, you have methyl, means the 1 carbon is attached. As you see, then you put the hydrogen. Here, there's a 1 bound around it. We need to have 3 more. This is H3. Here is 3, just need a hydrogen here. And so on, you can put the hydrogen around. Any question? Okay, so right after pack naming, you have, this is the longest chain, 1, 2, 3, 4, 5, 6, 7. This is your longest chain you possibly could have. Then you have to count from the side that gives this branch's lower number. I counted here 1, 2, 3, 4. So you have heptane because it's 7 in a main chain. On the third, fourth, and 4. See 4, 4. We say 3, 4, 4. We say tri because it's 3 of them. You have 3 methyl. Attach that. 3, 4, 4, trimethyl. Any question? Okay, I'm gonna give you some questions then. See, this is page 15. Do question number 1, all of them, and 2. Okay, do it for now and I will get back to you. Guys, yeah, this is for chemistry.